Hello and good day to all grade 8 students out there. Welcome to another video tutorial in grade 8 mathematics, where learning and understanding math is easy and fun. Without any further ado, let's get started. Today, I am going to discuss about factoring perfect square trinomial. Objectives of the lesson. At the end of this video lesson, the learners or the students shall be able to: number 1, identify whether a given expression is a perfect square trinomial. Number 2, factor the perfect square trinomial completely. And number 3, use the FOIL technique to check the factors of perfect square trinomial. But before we proceed to our topic, I want you to identify whether the given number or expression is a perfect square term or not. Direction: say yes if the given number or expression is a perfect square term. Otherwise, say no if the given number or expression is not a perfect square term. Are you ready? So let's begin. 9x squared. Is 9x squared a perfect square term? The answer is yes. So 9x squared is a perfect square term because 9x squared is the square of, you're right, it is the square of 3x. So the square of 3x, if you're going to multiply 3x by itself, 3x times 3x, that will give us 9x squared. How about the next one? 8m. Is this a perfect square term? The answer is no. It is not a perfect square term because, as you can see, the variable m here is not raised to an exponent of 2. So if there is no exponent of 2, it means that the given variable is not a perfect square term. So this one is not a perfect square term. Another one is 49. Is 49 a perfect square term or perfect square number? The answer is yes. It is a perfect square number because 49 is the square of 7. So if you're going to get the square of 7, that is 7 times 7, that will give us 49. How about the next one? 81x squared y raised to the 8th power. Is this a perfect square term? The answer is yes, it is a perfect square term because 81x squared y raised to the 8th power is the square of 9x y raised to the 4th power. So if you multiply 9x y raised to the 4th power by itself, we will have this product, 81x squared y raised to the 8th power. How about the next one? 125. Is 125 a perfect square number? The answer is no. It is not a perfect square number because 125 is a cube number. It is a perfect cube number. So 125 is the cube of 5. It is not a 125 is not a perfect square number, but it is a perfect cube number. So 125 is the cube of 5. So if you're going to get the cube of 5, 5 multiplied by itself 3 times. So 5 times 5, that is 25, times another 5. So it will give us 125. How about the last one? Negative 25 n squared. Is this a perfect square term? The answer is no, it is not a perfect square term because as you can see, there is a negative sign here. So always remember, a perfect square term has no negative sign. So it is always positive. So laging positive po ang perfect square term. So last time, you learned how to factor the sum and difference of two cubes. This time, you're going to learn how to factor the perfect square trinomial. So, what is perfect square trinomial? So, perfect square trinomial is in the form of a squared plus 2ab plus b squared. So, perfect square trinomial, according here, it has three terms, which are a squared, 2ab, and b squared. It is a special product or polynomials consists of three terms where the first term and the last term, which are a squared and b squared, are perfect square terms, while the middle term is twice the product of the roots of a squared and b squared. Therefore, the whole expression is called perfect square trinomial. So a perfect square trinomial is a polynomial where the first term and the last term must be perfect square terms. So how do we know that the first term and the last term are perfect square terms? As I said earlier, a perfect square term must be raised by exponent of 2. So when the term is raised by the exponent of 2, or if it is written with exponent of 2, then that term is a perfect square term. So like this, a squared and b squared, both terms, both variables are raised by exponent of 2. So these are perfect square terms. While the middle term is twice the product. When we say twice the product, it is multiplied by 2. The product of the roots of a squared and b squared. When we say roots, the square root of the first term and the last term. What is the square root of a squared? A. B squared is b. So therefore, uh, the twice of the twice the product of the roots of a squared and b squared, that would be 2ab. So if you're going to look at this expression, once you encounter this kind of expression, this expression is what we call perfect square trinomial. Now, let us identify if the, let's have an example. Let's identify if the given expression is a perfect square trinomial. So for example, x squared plus 2xy squared plus y raised to the fourth power. Is this a perfect square trinomial? The answer is, it is a perfect square trinomial. Yes, it is a perfect square trinomial. Why? So, in order to say that this expression is a perfect square trinomial, according to our meaning, the first term, according to the given expression, the first term and the last term must be perfect square terms. So as you can see, our first term is x squared, so this one is a perfect square term because it is raised by exponent of 2. How about y raised to the fourth power? Is this a perfect square term also? Yes, it is also a perfect square term because y raised to the fourth power can be written as y raised to the power of 2, and then open and close parenthesis raised to the power of 2. And then the middle term must be twice the product of the roots of the first and the last term. So first, to take note, our first term is x squared and the last term here is y raised to the fourth power. So getting the square root of those terms, so the roots are x and y squared. And then twice of the product of the roots, that would be 2xy squared. So this expression is a perfect square trinomial. How about another one? Y cubed plus 2y squared minus 36. Is this a perfect square trinomial? The answer is no. It is not a perfect square trinomial because as you can see, the first term here is y cube. So y cube is not a perfect square term because this term is raised by exponent of 3. So in this case, the entire expression cannot be called a perfect square trinomial. Now you already know what is a perfect square trinomial. We can now have an exercise. Show a thumbs up if the given expression is a perfect square trinomial and thumbs down if it is not. So show me the thumbs up if the given expression is a perfect square trinomial. Otherwise, show the thumbs down if it is not. Are you ready? Alright, let's have a first one. X raised to the fourth power plus 6x squared plus 9. So let's identify if this given expression is a perfect square trinomial. So, so what do you think? Is this a perfect square trinomial? The answer is thumbs up. So it is thumbs up because this expression x raised to the fourth power plus 6x squared plus 9 is a perfect square trinomial. So in order to say that this entire expression is a perfect square trinomial, the first term and the last term must be perfect square terms. So as x raised to the fourth power, this is a perfect square term because it is the square of x squared. 9 is also a perfect square number. 9 is the square of 3. So, so here, it appears that our A is x squared and our B is 3. So AB, so the product by following the pattern a squared plus 2ab plus b squared, so our AB would be 3x squared and twice of and then multiply it by 2 because we're going to get the middle term. So twice of the product of 3x squared, that would be 6x squared. So you're going to multiply 3x squared by 2 in order to get the middle term. How about the next expression? N raised to the 6th power minus n cubed m minus 25. Is this a perfect square trinomial? It is thumbs down. So why? Why this expression is not a perfect square trinomial? Because as you can see, so although the first term here and the last term are perfect square terms, but the middle term here is not twice the product of their roots. So this expression cannot be called a perfect square trinomial. So remember, in order to say that the entire expression is a perfect square trinomial, the middle term must be twice the product of the roots of the first term and the last term. How about the next example or the next one? A squared minus 10ab plus 25b squared. Is this a perfect square trinomial? The answer is thumbs up. So it is a perfect square trinomial because the first term and the last term are both perfect square terms. So perfect square terms ang a squared, and also 25b squared is perfect square terms. So a squared is the square of a, while 25b squared is the square of 5b. So now what is it appears that our a is a and our b is 5b. So ab is 5ab, and then getting the and then the middle term must be twice the product. So twice of AB. So our AB here is A and 5B. So AB is 5AB. So multiply it by 2. So you will get the middle term, which is 10AB. So 2 times 5AB will give us 10AB. How about the next expression? X raised to the fifth power minus 5x squared plus 2x. Is this a perfect square trinomial? The answer is thumbs down. It is not a perfect square trinomial. As you can see, the first term is not a perfect square term because it is raised by the exponent of 5. So how about the next expression? X raised to the sixth power minus 4x cubed plus 4. Is this a perfect square trinomial? The answer is thumbs up. It is a perfect square trinomial because the first term and the last term are both perfect square terms. So x raised to the sixth power is the square. This is the square of x cubed. While 4, the last term, is a perfect square number. It is the square of 2. So the product of those roots are, so their product is 2x cubed. And then twice of the product, so multiplied by 2, multiply 2x cubed by 2, that will give us the middle term, which is 4x cubed. Okay? How about the last one? M squared plus mn plus n squared. Is this a perfect square trinomial? The answer is thumbs down. It is not a perfect square trinomial because the middle term is not twice the product of the roots of m squared and n squared. Remember, in order to say that this expression is a perfect square trinomial, the middle term must be twice the product of the roots. So let's proceed. Now you already know how to identify a perfect square trinomial, or how to identify whether the given expression is a perfect square trinomial or not. We can now factor the perfect square trinomial. So how do we factor a perfect square trinomial? So there are two kinds of factor. We have two kinds of factors. So if a squared plus 2ab plus b squared is equal to, so the factors of perfect square trinomial is the square of the sum of a and b. Take note, if the middle term in the product is positive. So when do we say uh, what is the factor of a squared plus 2ab plus b squared? It is the sum of the square, or it is the square of the sum of a and b. So this will be the factor if the middle term is positive. So remember, if the middle term, so I am talking to the middle term. So I am referring to the middle term of the product, which is which is the perfect square trinomial. If the middle term in the perfect square trinomial is positive, which is 2ab, then the factor is the square of the sum of a and b. However, if the middle term in our product or in the perfect square trinomial is negative, then the factors is the square of the difference of a and b. So there are there is a difference between the factors of a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. So given the factors of the perfect square trinomial, it depends on the given sign of its middle term. So it depends on the sign of the middle term. So that will determine what will be the factor of the perfect square trinomial. So if the middle term is positive, I am talking to the middle term, or I am referring to the middle term of the product, which is 2ab. If 2ab is positive, then it is the square of the sum of a and b. If the middle term in the product is negative or negative 2ab, then it is the square of the difference of a and b. So that's the way how to factor the perfect square trinomials. So let's proceed. Okay, so let's have an example. If I have m squared plus 2mn plus n squared, how do we factor this perfect square trinomial? So first, let us determine if the given expression is a perfect square trinomial. So let us identify if this expression is a perfect square trinomial. So by looking at the given expression, we can say that this is a perfect square trinomial because the first term and the last term are both perfect square terms because it is raised by exponent of, you're right, it is raised by exponent of 2. And the middle term is twice the product of the roots of m squared and n squared. What are the roots of m squared and n squared? Mn. So twice of the product of mn is 2mn. So this is a perfect square trinomial. So after you determine, after identifying the expression as a perfect square trinomial, you can now proceed to step number 2, which is factoring the expression. So we can now factor the expression or the perfect square trinomial by following our, yes, this guide. So by following the guide, so following the pattern in factoring the perfect square trinomial, so as you can see, the middle term is positive. So if it is positive, then we must follow this factor, this pattern of factor. So the factor is the square of the sum of a and b. So what would be the factor? So it is the square of m plus n. So after you factor the perfect square trinomial, we can now check if the factors is the true factors of the perfect square trinomial. So square of the sum of m and n, so that is, so the entire expression m plus n is multiplied by itself. So you multiply m plus n times another m plus n. So using the FOIL, let us use the FOIL technique. So what is FOIL? FOIL means first, outers, inners, and lasts. So we're going to use the FOIL technique in multiplying these two binomials. So, so first, we're going to multiply all the terms that are first. First terms. So in this case, our first terms are m times m. So if we multiply m times n, it will give us m squared. And then what is the next? Outers. So we're going to get the terms that are in the outer the outer terms, or the outers, which are m and n. So multiply m and n, that will give us plus mn. And then after that, we're going to multiply the inners. Inners are the terms between. So what are the terms between n and m? So multiply these two terms, the inners, so that will give us plus mn. And then we're going to multiply the last. So it refers to the last terms. So what are the last terms? The two n's. Okay, so multiply the two n's, n times n, so that will give us n squared. And then, are we done? No, we are not done yet, because as you can see, we can combine the terms in the middle, which are mn plus mn. So we can combine these two terms. So if we combine these two terms, so our expression will be m squared plus 2mn plus n squared. So this is now our product. So it means that our factor is correct. So we get the original expression, which is m squared plus 2mn plus n squared. Let's have another example. X squared minus 8x plus 16. So first thing to do is determine if the expression is a perfect square trinomial. So let's identify if the given expression is a perfect square trinomial. So by looking at the expression, the first term and the last term here are x squared and 16. So according to the according to definition of perfect square trinomial, the first term and the last term must be perfect square terms. So x squared, is x squared a perfect square term? Yes, it is the square of x. 16 is also a perfect square number. So it is the square of 4. So our a here is x and our b is 4. So ab, that will be 4x. And then multiply it by 2, we get the middle term, which is 8x. So 8x is twice the product of 4x. 2 times 4x is 8x. And then once you determine that this expression is a perfect square trinomial, you can now proceed to step number 2, which is factor the expression. So we can now factor this one. So to factor, we're going to follow the pattern of this. A squared minus 2ab plus b squared is equal to the square of the difference of a and b. So as you can see, so why do we follow this pattern? Because as you can see, the middle term is negative. So if the middle term is negative, then the factor must be the square of the difference of a and b. So we're going to follow this format. The square of a minus b. So if we're going to factor x squared minus 8x plus 16, it will give us the square of x minus 4. So this is now the factor of x squared minus 8x plus 16. Now let's check if this is correct by multiplying or by expanding the fact by getting the product of the square of x minus 4. So to get the product, we multiply x minus 4 by itself 2 times, because if it is raised by power of 2, that means the entire expression x minus 4 is multiplied 2 times by itself. So we have x minus 4 times x minus 4. And then to multiply, we're going to use the FOIL technique. So again, just like in example number 1, when we are using the FOIL technique, we're going to multiply first all the terms in the first position. So in this case, we're going to multiply first the 2x. So x times x. So if we're going to multiply all the first terms in the two binomials, we get the square of x squared. And then next, multiply the outers. The outers are the terms that are that are that are outside the parentheses, or that are that are that are placed in the outer position. So x and minus 4. So when you are multiplying both terms, you should include their sign when you are multiplying. So x times negative 4, the outers. So we get minus 4x. Then next is multiply the inners. Inners are the terms between. So what are the terms in the middle? Minus 4 and x. So these are the inners. So if you multiply the terms in the middle of two binomials, we get minus 4x. And then we're going to multiply the last terms. So the last terms in the two binomials are negative 4 and negative 4. So multiply negative 4 times negative 4. So it will give us negative times negative is positive. So the sign will be positive 16. And then add the middle terms. The terms, since minus 4x and minus 4x are like terms, we can combine these two terms. So we have x squared minus 8x plus 16. Minus 4x minus 4x. So you just combine or add the two minus 4x. Minus 4x plus minus 4x will give us minus 8x. So this is now the product of the square of x minus 4. X squared minus 8x plus 16. So we come up with the original expression. So let's proceed. Alright, let's have another one. 4m squared plus 20mn plus 25n squared. So before we factor this expression, let us identify if this is a perfect square trinomial. So for 4m squared plus 20mn plus 25n squared, is this a perfect square trinomial? It is a perfect square trinomial. So, a perfect square, according to our definition, a perfect square trinomial consists of three terms. So, there are three terms here: 4m squared, 20mn, and 25n squared. So, this is correct. And then, the first term and the last term must be perfect square terms. So, 4m squared is a perfect square term because it is the square of 2m. So, that is our A. And 25n squared this is also a perfect square term because it is the square of 5n, which is our B. So, the middle term must be twice the product of A and B. So, our A, again, take note, our A here is 2m and our B is 5n. So, what is the product of A and B? 2m times 5n will give us 10mn. And then, multiply it by 2. Multiply 10mn by 2. 2 times 10mn will give us 20mn, which is the middle term. So, this is a perfect square trinomial. And then, after identifying the expression as a perfect square trinomial, we can now factor this expression. So, what is the factor of this? What is now the factor of 4m squared plus 20mn plus 25n squared? The factor is, you're right, it is the square of 2m plus 5n. So we already determined what is A and what is B. So our A here is 2m and our B is 5n. So the square of the sum of A and B is the square of 2m plus 5n. So this is now the factor of perfect square trinomial. Now let's check if this let's check if this is correct by using the FOIL technique. So multiply the square of 2m plus 5n, multiply 2m plus 5n by itself, 2m plus 5n times another 2m plus 5n. So using the FOIL technique, let us use the FOIL technique. So we have two binomials, 2m plus 5n times 2m plus 5n. So first, we multiply the terms that are first. So these are 2m times 2m. So if we multiply 2m times 2m, we have 4m squared. And then next is multiply the outers. The outers are 2m and 5n. 2m and 5n. So 2m times 5n will give us positive 10mn. So positive times positive is positive. That's why the sign here is positive. Then multiply 2 and 5, that is 10 mn, mn. And then next, multiply the inners. So the inners are 5n and 2m. So multiply 5n and 2m will give us positive 10mn. And then multiply the terms that are last. What are the last? The last terms. 5n times 5n. So if we multiply 5n times 5n will give us positive 25n squared. N times n, multiplying same base, add their exponent. So the exponent of n is 1. So although there is no exponent 1, it is understood that there is an exponent of 1 here. So add their exponent, that will be 2. And then the next step is add the terms that are alike. So as you can see, 10mn and 10mn are like terms. We can combine these two terms. 10mn and 10mn and 10mn. So Combining the two will give us 4m squared plus 20mn plus 25n squared. So this is now the product. So we come up with the original expression. So 4m squared plus 20mn plus 25. So it means that the square of 2m plus 5n is the factor of 4m squared plus 20mn plus 25n squared. It's time to test yourself. Get a pen and a sheet of paper. You can pause the video to, to answer this exercise. Are you ready? Direction. Factor the following perfect square trinomials. Alright, let's see if your answer is correct. So our number one is x squared minus 24x plus 144. So first, let us identify if this given expression is a perfect square trinomial. So is x squared minus 24x plus 144 is a perfect square trinomial. So by looking at the expression, x squared is a perfect square term and 144 is also a perfect square number. So x squared is the square of x and 144 is the square of 12. So therefore, our a here is x and our b is 12. So ab is 12x. And then the middle term in the product must be twice of ab. Our a is, remember, our a is 12x. Our AB is 12x. So multiply it by 2. 2 times 12x will give us the middle term, which is 24x. So it means that this given expression is a perfect square trinomial. So we can now proceed to the next step. Factor the perfect square trinomial. So what is now the factor of this trinomial? So in factoring perfect square trinomial, always look for the middle term. So if the middle term is positive, then we follow the factor, which is the square of the sum of a and b. However, if the middle term is negative, then we must follow the factor, which is the square of the difference of a and b. So in this case, our middle term is negative. So we follow the square of the difference of a and b. So what is now the factor? Therefore, the factor is the square of x minus 12. Now, to check if this is the true factor of x squared minus 24x plus 144, let us get the product. So to get the product, we expand this factor, the square of x minus 12. So multiply it by self 2 times. So x minus 12 times x minus 12. So using the FOIL technique, let us multiply these two binomials using FOIL. So let us multiply the first terms, x times x, so that will give us x squared. And then next, the outers. The outers are x and minus 12. So multiply x minus 12 will give us minus 12x. And then inners, multiply minus 12 and x will give us minus 12x. And then the last terms in the binomial, minus 12 and minus 12. So multiply minus 12 times minus 12. That will be positive. It will become positive because negative times negative is positive. It will become positive 144. And then combine all the terms that are like terms. So minus 12x combine minus 12x and minus 12x will give us, so this is now our product, x squared minus 24x plus 144. So we come up with the original expression. So it means that our factor is correct, the square of x minus 12. Okay, next. Okay, number 2. Factor 36 plus 12y squared plus y raised to the fourth power. So let us identify if this given expression is a perfect square trinomial. So by looking at the expression, so 36 is a perfect square number. It is the square of 6. And y raised to the fourth power is a perfect square term. It is the square of y squared. And so our a here is 6 and b is y squared. So AB is 6y squared. And then multiplied by 2, multiply 6y squared by 2, that will give us the middle term, which is 12y squared. So this is a perfect square trinomial. So what is now the factor of this expression? So since the middle term is positive, then our pattern or our factor for this one is the square of the sum of a and b. So, therefore, the factor is the square of 6 plus y squared. Our a is 6 and our b is y squared. Now, let's check if, if the square of 6 plus y squared is the true factor. So, to check, we're going to multiply. So, let us expand the square of 6 plus y squared. So the square of 6 plus y squared, that that will be multiplied by itself. Multiply 6 plus y squared by itself. So 6 plus y squared times 6 plus y squared. And then to multiply these two binomials, we're going to use the FOIL technique. So again, let us multiply the terms that are first. The first terms, 6 times 6, it will give us 36. Next, the outers. The outers are 6 and y squared. So 6 times y squared will give us, you're right, positive 6y squared. Inners, y squared and 6. Y squared times 6 will give us positive 6y squared. And then the last terms in the binomial, y squared and y squared. Y squared times y squared will give us, you're, you're correct, positive y raised to the fourth power. So same base, add their exponent. 2 plus 2, so our exponent is 4. And then to finish, the to get the product, we simplify this by adding the terms that are alike. So here our like terms are 6y squared and 6y squared. So add the terms in the middle. 6y squared plus 6y squared will give us, so this is now our product, 36 plus 12y squared plus y raised to the fourth power. So this is now our product. So we come up with the original expression. So it means that our factor, the square of 6 plus y squared, is correct. Next. Okay, let us factor this one. 4s squared minus 8s plus 4. So let's see if this given expression is a perfect square trinomial. So 4s squared minus 8s plus 4. So this is I think this is a perfect square trinomial because the first term in the expression is a perfect square. It is the square of 2s, while the last term here, which is 4, is also a perfect square number. So it is the square of 2.
Then the middle term, in order to be called this perfect square trinomial, the middle term must be twice the product of the square roots of the first and the last term. So the first term is 2s. The first term, the square root of the first term is 2s. The square root of the last term is 2. So 2s times 2, that is 4s. And then you get the twice of that, multiply it by 2, that will be the middle term, which is 8s. So the entire expression is a perfect square trinomial. So what will be the factor? The factor would be, yes, it is the square of 2s minus 2 because um, 2s is our a and our b is 2, and it is minus because the middle term is minus or negative. So that's why the factor of a perfect square trinomial whose middle term is negative will be the square of the difference of a and b. And then to check the factors, let us multiply. So multiply 2s minus 2 by itself. 2s minus 2 times 2s minus 2. So using the FOIL technique or the FOIL method, let us first multiply the first terms, which are 2s times 2s. That will give us 4s squared. And then multiply the outers. 2s times negative 2 will give us minus 4s. And then multiply the inners or the inner terms. Negative 2 times 2s, it will give us negative 4s. And then multiply the last terms, which are negative 2 and negative 2. So that will be positive 4 because negative times negative is positive. And then multiply 2 times 2 will give us 4. And then to complete our answer, combine the middle terms, minus 4s plus minus 4s. So that will give us, so we come up with the original expression, 4s squared minus 8s plus 4. So this is now our final answer.
Okay. For number 4, we have 49a squared plus 42ab plus 9b squared. So first, before we factor this expression, let us identify if this is a perfect square trinomial. So, uh, as I see, this expression is also a perfect square trinomial because 49a squared is a perfect square term. It is the square of 7a. While the last term 9b squared is also a perfect square term. It is the square of 3b. So multiply the square roots of the first and the last term, that is 7a times 3b will give us 21ab. And twice of that, when you say to get the twice of 21ab, you just multiply 21ab by 2. It will give us the middle term, which is 42ab. So therefore, this whole expression is a perfect square trinomial. Now, to factor this one, the factor of a perfect square trinomial whose middle term is positive, the factor would be the square of the sum of a and b. So that will be, our a here is 7a and our b is 3b. So therefore, the factor is the square of 7a plus 3b. Okay? And then to multiply, to check if this is the correct factor of 49a squared plus 42ab plus 9b squared, let us multiply. Multiply 7a plus 3b by itself. So to multiply these two binomials, we use the FOIL method. So again, what is FOIL? FOIL is first, outers, inners, and last. So we're going to multiply first the first terms in the binomial. So the first terms here are the two 7a's. So multiply 7a times 7a, that will give us 49a squared. 7 times 7 is 49, and then a times a, same base, you just add their exponent. And it is understood that a is raised to the power of 1, so you just add the two exponent of 1, that will be 2. And then multiply the outers. What are the outer terms? 7a and 3b. 7a times 3b will give us positive 21ab. And then multiply the inners. The inner terms are 3b and 7a. That will give us 21ab. And then last terms, the last, multiply 3b times 3b, it will give us 9b squared. 3 times 3, 9. B times b, same base, add their exponent, so it will be b squared. And then to finish to complete our answer, you add the middle terms, the terms in the middle, which are 21ab plus 21ab. So our answer will be 49a squared plus 42ab plus 9b squared. So we come up with the given expression. So this is now our answer. It means that our factor is correct. So next, and for number 5, our given expression is a squared minus 16a plus 64. So factor uh, this trinomial. So to factor the perfect square trinomial, or this trinomial or expression, we have to identify if this expression is a perfect square trinomial. So as I see, a squared minus 16a plus 64 is a perfect square trinomial because the first term and the last term here are perfect square. A squared is the square of a, that is our a, and 64 is the square of 8. It is our b. So therefore, our the middle term must be twice the product of AB. So our A, again, our A is A, our B is 8. So AB is 8A. Then multiply it by 2. 2 times 8A will give us the middle term, 16A. So therefore, it is a perfect square trinomial. So what is now the factor of this one? The factor is, you're right, it is the square of a minus b. Our a is a and our b is 8. So it is a minus b, a minus 8, the square of a minus 8, because the middle term is negative. Remember, when the middle term of a perfect square trinomial is negative, the factor is the square of the difference of a and b. And then to check if this is the true factor, we multiply a minus 8 times a minus 8. So to multiply these two binomials, we use the FOIL technique or FOIL method. So first, let us multiply all the first terms. A times a, it will give us a squared. Then multiply the outers. A times negative 8 will give us minus 8a. Then multiply the inner terms. Minus 8a, minus a, minus 8 times a will give us minus 8a. And then the last, minus 8 times minus 8 will give us positive 64. And then to complete our answer, we add the terms in the middle, which are minus 8a and minus 8a. So it will give us, so that will be minus 16a. So our answer is a squared minus 16a plus 64. So we come up with the given expression. So it means that our factor is correct. The square of a minus 8. Did you get all the correct answers? Great job. Please like and share. And don't forget to click the subscribe button for more updated and upcoming video tutorials. That's it for now. Thank you for watching.